Hello, so in this video I want to talk about something which people ask me all the time, which is, well, we've got variance, I know how to work out variance, I'm happy that it's just the mean of all the distances, so it gives me kind of a mean of the total spread, but then why should I bother square rooting it to find standard deviation? Or more importantly, or perhaps more relevantly, why would we give this the name variance and then we call this, which is just the square root of variance, another name? You know, normally if we give a name to something in maths, it implies it's pretty important. So in other words, what is the difference between standard deviation and variance? So I've got here all the different formulas which we've looked at so far for how to work out the variance, okay? And they all just basically look at finding the mean of the distances from the mean, okay? And then the standard deviation, of course, is just the square root of the variance. Nice and easy. But what's the difference? Well, let me try and show you with this example here. So with this example here, I've got the mean, which is, you know, this white bar here, and I've currently got the mean to be 2. Okay, it doesn't really matter. By the way, I didn't feel that I explained very well, you know, why we should take away the mean in the previous video. If you think about transformations of graphs, okay, just very quickly, if you think about transformations of graphs, okay, you can have your vanilla x squared graph, so y equals x squared graph, okay, and then you can also do transformation to it, which is just shift the whole thing up by 2, so y equals x squared plus 2, okay, or we can shift it up or down. So this plus 2 just corresponds to the kind of the shift which we have. So if I just then try and draw it out on a number line, you know, so let's say, for example, my mean is x bar, which is 2, then I've got all these sort of different values which are kind of around it. Well, then taking away, you know, my variance formula up here involves taking away a sort of an x bar squared. Okay, all that's simply doing, and I'll take it away at the end more importantly, all that's simply doing is just shifting all the data down to make the mean 0. Okay, so it's just simply shifting all the data. That's all it's basically doing. So back to it then. So why should I call the variance one thing? You know, why should I stop at the variance? Because it makes sense then, you know, standard deviation, I square something, I square root it, you know, I take -3, I square it, then I square root it, and I end up back at 3. So that makes -3 positive, basically. But why should I sort of pause just before? Why should I pause just before I square root something and give it a special name? You know, it implies that there's some importance there. It implies that, you know, it's important in certain situations. So in other words, why should I pause before I square root it? And the answer is with this data here. So looking at this data here, I've got, you know, if you like, my speed is 4 here, my speed is 1 here, my speed is x3 here, if you're following from my last example. But these are just simply my data points, okay? Then, of course, my mean is in the white line there. Then one of my data points is 12. So fairly obviously, if this was just my data, you would look at that, hopefully, and say, well, that data point is quite clearly an outlier. That data point is quite clearly an outlier. Now, if you remember right back to when I was introducing spread, I said that spread is a really good way of removing outliers. Right, well, now I'm looking at the variance, which is all to do with looking at kind of, it's still to do with variation, still to do with spread. So in other words, I should still be able to spot outliers. Well, if I look at variance, then I can do. Because if I try and calculate this, so this is the formula for my variance. The variance is sort of my distances, basically. So my green distance is here. So this green distance, this green distance, this green distance, which is all I'm calculating with this formula here. So all I'm calculating with this formula here, so this bit inside the brackets there, I'm just calculating distance, the x minus the x bar bit. Okay, then I'm squaring that distance to make them all positive, then I'm taking the mean, basically. So if I just very quickly work this out, so my x1 is 4, so I've got 4 minus 2, so I've got 4 minus 2, okay, then I'll end up squaring that. Okay, then I'm adding that to my next distance, which is 1, minus my mean, which is 2. Okay, and then I'll end up squaring that. And then if I do the third one as well, just very quickly, so my third one is 3, so I'll end up with, so unfortunately it's running off the screen, so I'm just going to have to move over. There we go. Plus, so plus 3 minus my mean, which is 2, and I'm squaring it. And then my final value is all the way up here. So my final distance is all the way up here, the outlier. So it's going to be 12 minus my mean, which is 2. So plus 12 minus my mean, which is 2. Okay, and then I'll end up squaring it, and then I just divide through by the number which I have. So this is my variance, and I just end up dividing through the number which I have, which is 4. So let's just try and calculate this, shall we? So I've got 4 minus 2, which is 2. So I've got 2 squared, plus 1 minus 2, which is minus 1 squared, plus 3 minus 2, which is 1 squared, plus 12 minus 2, which is 10 squared. Then I'm dividing through by 4, so let's have a look. So I've got 2 squared, which is 4, plus 1 squared, plus 1 squared, so 1 squared is 1, sorry, 1 squared is 1, so minus 1 squared is 1, 1 squared is 1, plus 10 squared, which is 100 over 4. Now, which one did I say my outlier was? I'm just going to pause. Which one did I say my outlier was? I said this one was my outlier. So my x4, which corresponded to this last term here, which corresponds to this last term here, which corresponded to this last term here. Now, what do you notice? I've got 4 plus 1 plus 1, but then I'm adding 100. So 4, 1, 1, and then 100. 100, compared to all my other numbers, is way out there. It's way on the sort of the realms of the universe. Absolutely massive number compared to 4, 1, and 1. Right? So, in other words, it makes sense for me to pause there. So, in other words, when I'm working out the variance, it makes sense to me pause, because the thing is, if I square root it again, I take this 100, if you like, all the way back to 10. Okay? Because the square of 100 is 10. So, it makes sense for me to be paused before I take the standard deviation, because I'm able to spot outliers really, really quickly and efficiently, because I end up with ridiculously big numbers. And that's true as well if I had, if this was down below the line. So if this was down below the line, so way down here sort of somewhere, so this would be, let's say for example x4 was at negative 12. Sorry, I'm sort of running into my previous working. Well, that doesn't matter, because I'll just still have negative 12 minus 2, which comes out as negative 14. So negative 14 squared becomes it's negative 14 squared. So 14 squared works out to be 196, which again, in the grand scheme of things, sort of relative to all these other numbers, 196 is massive. So in other words, what pausing before I take the square root, because the thing is, if I square root it again, it brings it back down to a sort of a relatively small number. So the thing is, what the variance does, what the variance is able to do, is because I'm squaring it, okay, if I end up with an absolutely ridiculously massive number, it means I've got outliers in there. So I'm able to spot outliers really easily, okay? But then the standard deviation is just simply square rooting it, so it takes it back to a number which is more proportionate to the actual distances. So it's taking more the average of the distances. It'll give me kind of an average distance, if you like. Another way which you can think of it, though, is imagine if I'm taking a walk. So let's say, for example, I start here, okay, and I end over here, and I end up taking sort of a fairly random sort of walk, if you like. So taking a really quite random walk. Well, the average of that walk would be something that looks like that. So that's the average of that walk. Maybe if we do a different colour. So this is the average of my walk, okay? My variance is looking at the overall distance that I've travelled, the overall kind of spread of the distance. That's what my variance is basically doing, okay? But my standard deviation, if you like, my standard deviation is looking at the size of each individual step. It's looking at the size of each individual step which I'm taking. Okay, so if you like, it's my individual step. So that's what the standard deviation is. I often think of it like that. So the variance, another way of thinking about it, is that variance gives an idea of overall spread. Okay, whereas my standard deviation, if you want to use that as kind of walking example, gives me my individual steps. Sorry, my handwriting has gone awful. Individual steps. Okay, so that's another way which you can think of it. So it makes sense then. The difference between variation and standard deviation, variance and standard deviation, is just simply one. The variance will be able to spot the outliers really easily. The standard deviation just gives me my average step, my average distance. Okay, but it makes sense to pause before I take the square root. Another way which you can think of it is imagine I'm taking a walk. All my variance is just giving me the overall spread which I'm travelling from the mean. Okay, whereas the standard deviation kind of looks at my individual steps which I'm taking.